recording. Good.
It's on the distinction between argument modeling and meta arguments, meta modeling.
Yeah. So I agree with a lot of what you're saying about there's a process for agreement for saying this statement is, something we can work from. Hi, Tim.
Hey, Tim.
I'd like to spend 5 minutes finishing a conversation with Stephen, and then we can go.
We'll time box it just to be safe.
Yeah, let's time box it.
It's Felix's day, so yeah, it's up to him.
Yeah, like officially, it's I hand over the control to you, Timothy, for the process, but I, for the next 5 minutes, belong to Marc-Antoine.
Okay.
You still have the master control, so yeah, go for it.
So agreed that there is a process which is totally a separate concern, separate domain about how we accept arguments. And as you said, this may or may not use argument modeling as a way of do that. I agree with that much, but I'm saying often meta arguments will be used in that process, whether they're modeled or not in that process.
Mm-hmm.
And then when they're used, they may become part of the argument process, of the arguments, in which case modeling meta arguments remains a core concern.
Yeah, but so I never disagreed with that. I question
I
what it means to become part of. That's what it's all about, which I summarized in the last message in one text. What did I say? Like, when do you do the assuming?
Yeah,
right?
And I'm saying it might not be discontinuous. If we're using, if we're modeling meta arguments, which I agree is one option, but not the only one, then we may have, kind of, this is certain up to a certain degree. And for example, in a consensus model, it would be depending on the degree of consensus on it.
Yeah,
and then
that's the process that then does the assuming. But my only point
But there wouldn't be a threshold necessarily. You're assuming a threshold.
No, there has to be a threshold. Otherwise, the model has no assumptions built in and becomes useless. That's my whole point. Like the process resolves stuff to establish that a snapshot of a model. If you don't at any point have a threshold, which is established through a process, which may be done through argument mapping, then the model becomes useless. Because you cannot consider anything equivalent. My point is that within an argument model, you need to assume equivalence. That is what you are modeling. If you don't assume equivalence or non-equivalence, the argument model becomes less useful. Useless almost, I would say.
Yeah, and this is what I'm contesting. If you have a discontinuous measure without threshold, you can say, well, you can put a threshold anywhere or everywhere.
Yeah, but takes a use case because you are modeling equivalence because you want to show all supporting arguments of one claim also to the supporting arguments of an equivalent claim.
Yeah.
If it's not like yes or no, if it's not binary, how do you decide to do that or not? What UX? How? When? Like this is one specific UX case. Are you going to show them or not?
I would show basically a list saying these are the top ones, and then this is the progressively less and less agreed upon stuff. And I mean, there's a point where you say, I'm not buying this, but you could.
Yes, okay, I agree that is possible, but then, then there's a distinction between the thing we do model, which is relevance. Less and less relevant, and yet another thing in visualization you have to show like maybe or maybe not equivalent. It just removes of the usefulness of the model. If you model it as equivalent, the whole point is that you display it as equivalent, and you would just show the supporting claims anywhere in equivalent claims as well.
What I would want to do is to separate, and I'm closing with that. Separate this is. Kind of everybody agrees with this except a few French people, and these ones are contested. It may be equivalent, but they're contested. I want a measure of contestedness, and that to be part of the conversation.
But that doesn't rule out. It can be part of the conversation if your process supports it.
Yeah, exactly.
The only thing is what we're saying is the process does not have to support it.
There I agree with you.
Distinction between argument modeling and meta-argument modeling.
There I agree with you.
Okay, so then we aligned.
Okay, good. That's it. End of that conversation.
Wow, that was actually kind of time box. Nice.
Tim ran off though.
And Tim ran off. Yeah.
Yeah.
Okay, but yeah, we're within time. 2 minutes. Let's just wait. Maybe you can screen share already, Marc-Antoine, because we need to.
Yes,
good idea.
absolutely. Okay. Use cases.
Sorry, dog walker showed up.
No problem. And
You should do one of these meetings while dog walking yourself.
I'll just put a GoPro on her and let her. We can have her participate too, because I'm not going.
I mean, I have good
Strap my
experience
cell
with
phone on her.
remote walking and talking with someone. It's like
Screen sharing
it's
is
like
a problem, I
having a
guess.
walk together, but not in person, but remotely, which works very well for thinking and discussing.
So I think we ended up with an invalid state or potentially invalid state of the model in the bottom left corner, if I'm not mistaken. And I wanted to verify whether we can fix it or whether it's already fixed with the ongoing changes.
yeah, I think that's where we were. Let me get. So this is, yeah, we're looking at this one. Let me just check that. I'm not sure. No, the Java thing is not running. Just. Oh, geez. Okay. We were looking at whether yeah, it's okay. Just
So if we just look at claim and forget about the support for now.
the second the stupid thing started, then skip break. Thank you.
Argument, it's actually no. If we forget about argument for a second and only look at claim and then to the negation relation that exists between claims, can we do generate sentence as such? Like if sentence is null and you call generate sentence, that then assumes that there's a negation available, otherwise you get a runtime exception, I guess, or
yeah. That's what I think will happen. Either the sentence or the negation, or if it's an argument, then the mechanism is to construct it from the conclusion.
Yeah, we can look at argument next. I'm just only looking at claim for now to see.
Yeah.
So it could potentially find an equivalent claim and then even make a negation of that one, or it could.
Yeah.
No. Well, if it's
so generates. I'm tempted to do this generate sentence from negation, or calling it like being more explicit about that.
But it's not always negation.
No, but in the case, and then have an argument, a method, generate sentence from conclusion and premise, or from components. You know,
I mean, it's essentially all you know is the sentence is null.
Yeah.
So take a claim, the sentence is null, maybe there's a negation, like, and then you just add is false to the sentence of that negation.
Mm-hmm. And I think we even had a note that either the sentence or the other one has a negation, but no, that may have been lost.
Or you simply find an equivalent sentence, but it's a bit odd. I guess it doesn't make sense that, yeah, I guess you would also want to limit one claim being equivalent to another claim if that claim doesn't have a sentence. Or no, maybe it can be. Yeah, you could say the earth is true, is false, is equivalent to,
well,
if earth is round, it's not, well, you know what I mean?
If you have 5 equivalent sentences, each of them has auto-generated negation, those are presumably, the negations are presumably equivalent to one another, and they all start up with an empty string. So that's a case where they would have an equivalent without sentence.
Yeah, it might work. There's a lot of invalid potential state, but we know that about this model so far. Okay, I think that might work. Then looking at arguments, the main reason we added the Boolean supports was to resolve the problem I identified, correct?
Yes.
I think it's reversed here. The top one, in the model, it should be called argument with a premise and a conclusion. And in the bottom model, it's still a support because you only have support as a relationship.
In the top model, it's also support because the Booleans are called negated premise and negated conclusion. It's purely semantics at that point.
No. Yeah, no, I don't think it is purely semantics.
In the top model?
No, either way. The fact that one is support and one is argument, and they are the way they are. In the top model, it's support because it is actually support of...
Support is assumed.
Yeah, support is assumed. And the other support depends on the Boolean supports.
Exactly.
We changed it. It was support. And then we said we can't handle a position cleanly with that. So we changed support to argument and said there's a Boolean support. Because support is not the same as negation. Support opposition is not the same as negation.
That's a weird hybrid model. What we were saying was on the bottom one that we were going to have it be support, and there's only support. And when you create a support, you need to create the negation. And the problem with that is you don't know which one was the original and which one is the negation. And so you would need a negation and flag, or you would need like a reference to the originator, right?
Right.
Yeah.
Okay,
so,
fair enough.
So I agree with that point, that that's why the bottom model currently is wrong, or a weird hybrid.
Okay, back to support. I'm fine with that.
Yeah, but that doesn't resolve the issue.
It doesn't resolve that. Then that's not the Boolean. The Boolean would be saying is negation for that.
Yes. Yes, which you need in order for the generate sentence method to work on support. I think this might work.
Is negation? It's not clear to me.
Yeah. I would almost, instead of calling it is negation, to make it a little more intuitive, call it
is basis.
Does not support.
I would do an enum, it's support or it does not support, which can be materialized as in a Boolean. But I mean,
what about is original instead? Is basis or is
no, the question is what is, like, is it about the claim or is it about itself?
It's about
the support. It's about itself.
I honestly, if we keep the bottom model, then I would name it not support. I would call it argument, and I would have a Boolean that says is support, or an enum support or does not support.
No, but because when you call it is support, then you're implying that what is the opposite of is support?
False.
No, yeah, but people would read that and think, oh, the opposite of support is oppose.
But
and that's not what it is.
It's a model. It's not what people would read.
Yeah, but people will read it. Like people outside of us at some point would have to look at the model and understand the model.
Okay, so I agree that for many reasons like that, I don't like the bottom model. I still don't.
I understand. Yeah. But just in case of, is positive form or is originator or is whatever, but is fine.
The problem is then right now in support, it's really weird. You have a Boolean that says is positive form, and then you have a relation of that support to another support. Just draw the instance diagram, right? You have one support with is positive form true, to another support with the same premise and conclusion, where is positive form is false.
Which has a negation link.
They have two edges to each other with negation. That just looks weird to me. Then I would much rather.
I understand, and you're right. We should do an instance diagram. I should have. I wish I'd taken time out to do that. But
I've got a suggestion. Another suggestion. We can do an instance diagram. I think it's perfectly valid. But the other option is, I would tend to reify negation, and then it will be much clearer which one is the originator and which one is the negated. Now, in the case of a claim, it's a bit arbitrary, but in the case of a support, it would not be arbitrary, and that's the whole point. If the negation is reified, then it's easier to see that it has directionality.
That's essentially what the top model does. The top model reifies negation. The bottom model just has two edges and two claims can.
No, but it's reifying it through the Boolean is positive form, right? It is doing it. Yeah.
May I have another idea? Instead of instantiating the negation, why don't we have in the model something like a negation operation that can be applied to claims, and then it kind of.
That's how you create the instance.
But you still need to reference that thing. So if it's something you're creating on the fly through a method or something, you can't reference it unless you've created it once and it's permanent. And that's the problem, is you need to be able to support the negative form of a support.
You need to record the natural language sentences also. And this is why you want to materialize the opposing claims.
Yeah, I'm saying materializing, but like materialize the operation, like a wrapping thing.
But what the operation, like, how would the operation know which ones are the negation unless it's recorded in the structure of the model, right? How do you know what's your negation? If you have a bunch of equivalent things here and a bunch of equivalent things there, and what is the negation of another, how do you know they are? Unless you've materialized it through a relation, a many-to-many operation. Now, what I was proposing is, in a classical relational database, this would be a table. You know, it would be a link, n table. Do we want that n table to become an object in model or not? And it's not my model, so I'm agnostic on this in this model. I'm not agnostic on this in general.
I think all of this is overcomplicating it. If you want to model claim and support as an inheritance hierarchy, again, Liskov substitution principle applies. If you want to model negation as edges, that means that the only place where something is a negation or it's not a negation is modeled is in the instance. In the case of claim, it's in the sentence. But there's no the sentence may be null for support, meaning you need to model it elsewhere, meaning it needs to be some Boolean that represents how you want to render the sentence within support. And in this case, it is the is positive form that captures it. But it's just a bit weird because it's actually the same as saying that the Boolean there represents supports or does not support, because that's literally what it represents in the same way that in claim, if the claim says supports or does not support. Right. Imagine there is no support. A supports B is a claim. There is no support clause here. A does not support B is a negation of A supports B. That entire relation between these two instances of the claim is encapsulated as two claims with the negation edges between them. If you then incrementally formalize it, and rather than just saying A supports B, you actually model that as a support right now, which I would call an argument. You remove the text support or does not support, and you represent it as a Boolean instead. That's all that's happening here. Does that make sense?
Yeah, yeah, and that's why they're equivalent models. They should be supporting the same set of features, right? So yeah, I think we're good as long as we agree that what's there supports or handles what we wanted to, what we have so far. Yeah, because the real decision point is going to come later on with more complexity.
It does, but it's just very confusing because the support clause right now is both support and does not support. That's the only confusing thing. The support clause represents.
It's not supported. And yeah, okay. It's.
I would call it clause arguments, and I would have an enum that either says supports or does not support.
What about maybe support?
No, there's no maybe.
No, as the name. Supports are not.
Yeah.
Supports are not. It's
support or not, yeah. But I mean.
Yeah. I mean, you have claim and then you have opposite claim, negation, but you just call it claim. I mean, I guess a negation is still a claim. So that makes
Imagine
sense.
implementing generate sentence for the support clause. if is supports A supports B. If not is supports A does not support B. That's what you would output.
Yeah.
Well, so that's why just write that method, and then it will become more obvious which one is more legible.
Well, I don't see what the difference is. Like if you're generating a sentence, you can generate the same sentence with both models.
Yeah, but I don't think we need to talk about it too much. I just find.
Yeah, the question is, are they equivalent models or not? Is something
they are just renaming support and the Boolean. They are exactly the same. Just renaming support to argument and is positive form to.
Well, they're not because of the string cardinality and the way. Basically, here the equivalence class is reified in Stephen's model and is implicit in Tim's model.
Right.
Yes.
True.
That's why I prefer the top one. But if we want to, I'm up with keeping
So do I.
either. But if we keep the bottom one, then I only suggest to rename support to argument because it is more legible to me. But,
okay, so what do you think, Tim, if we rename support to argument and then the Boolean becomes is support?
in the bottom one.
Okay.
Okay.
That's fine. Yeah.
Good. Okay, for now.
Yeah, and for me, all of this makes sense now. And yeah, there's reasons why I prefer the top one, but we need to look at the because Tim likes the bottom one for, and actually that there is some
I'm not even. Well. Yeah, I'm not convinced that I like the bottom one better. Intuitively, at least the way I pictured it in my head, it'll become better for some later stuff, yes. But it may turn out to be no different. So
yeah, but now we have both, so I think we can continue with the use case list from here, and then just keep a note.
Can I take 2 seconds to compare this?
Yes, I wanted to ask that. Yeah.
Because what we have, the argument. The claim here, this Tim's claim, which is the non-equivalent, is very close to my symbol, which can be in context or out of context and blah, blah, blah. And the thought proxy is the equivalence class, which is Stephen's claim, right?
I'm not certain I can follow that. Because now, I mean, these are 2 separate models.
I know.
I don't see how you can point to.
I know.
Okay.
So Mark Antoine was just the equivalence class thing, Stephen, makes sense to you or not? That in your model, the claim class is the equivalence class over the different, because it shows you that many sentences are equivalent, basically, because it's a collection of sentences.
Yeah. And why is equivalence clause in the right model? Because I don't see that.
What I'm saying is the thought proxy here is an equivalence class of symbols. Okay. So the thought proxy maps to your claim, to Stephen's claim, and the symbol maps to Tim's claim that way.
Yes. Yeah. Okay.
Okay. Mm-hmm. And then, symbol in context, decontextualized symbol, there's all these other things, but they're kind of accessory there. And then the whole thing about argument, I make the argument hierarchy on the thought proxy. So that way I am closer to Stephen's model because I'm basing the argument modeling, support modeling on the equivalence class and not on the symbol. But otherwise, we're not that far is what I'm trying to say.
Yeah, I see that.
Good, that's it. Let's now proceed.
And Timothy, you're the benevolent leader, so I would say pick a model to continue the use case process with. I'm fine with either. I think if we make a note, we have 2 at this stage.
I don't see a need to pick one. Yeah, we keep them both. Okay. If there's an evolution, I don't think it'll take that much to evolve. Or if there's an evolution, it's a good testing point for is one suddenly more interesting.
Yeah. Fair enough.
Yeah. So where's the spreadsheet? There were some trivial ones that are on Jamie's.
These, because they're equivalent.
Yeah, I think they're pretty much already handled, but it's quick to check. Let's take them in order. 17, even though it's maybe more complicated than the others.
A claim that is created in support of another claim can be identified as supporting the truth of that claim. So here we have A supports B and C supports A, really. It's not supporting the link, it's supporting the premise.
But isn't that what any support is?
Yes.
Okay, so it just
so what this does in our models is the difference between the truth and the relevance, as this wording has it, is the difference between supporting a claim and supporting an argument of support, right?
Yep,
exactly.
I'm in line with that.
So does that mean we're done? Completed?
Yes.
Okay. Let's see if it had an earlier expression quickly. A claim is support.
We don't need to merge. I'm okay with.
For me, it's the same as a claim in support of another, and
that's it.
And so that would say to argue that it's true or something like that, right?
Simply, right.
Yeah.
Claim is created.
Okay, cool. I would maybe put a mark that's saying this reduces to basic support.
You can put that in if you want.
Yeah.
Maybe do it on a new line. That's fine. It's there.
The new lines are a bit hellish.
I think
Control Enter.
It's Shift Enter or Control Enter. Every single interface has its own.
It's Option Enter on the Mac. Yes.
Yeah.
Okay.
Okay. A claim is created in opposition to the relevance of another claim. So this is the supporting the relevance. Yeah, opposing the relevance. Which can we see the models?
Yes.
Well, let's see the example just to make sure. So there is global warming is the conclusion. There was a cold spell in the central US in 2018, undermines, so opposes there is global warming. So you have, in this case, an argument opposing a claim. And then you have local extreme events in either direction do not cancel a global trend. So that opposes the support.
So it supports the negation. It supports the negation of the original support, basically, as Felix was saying.
Yeah, right. Which we have modeled. That's what we just talked about.
So
So in the top model, it would be conclusion, negation, true.
Yeah.
And premise, negation, false. And in the bottom model, it would just be that the bottom claim would have an argument claim targeting another argument whose Boolean is support is false.
Yeah.
You follow that?
On the first one, I would have said it. I think the original is true, and the secondary is true, false.
No, the original was the first one, premise. So it'd be true, false.
True.
So you have a claim, global warming, and then you have the first argument is, oh, it's not global warming because it was cold yesterday or whatever. And so that would be targeting the false. True is negation. Yeah.
No, no. I had not realized that there was a cold spell undermines. Okay, so it was true, false. It was true, false. I was thinking the general case was true. So this, in a way, it's okay. It's fine.
It's actually the opposite. It's confusing because
negation. Yes. Yeah. Okay, but basically, premise true negation. Premise true negation false. Conclusion false, and then the secondary is premise true. Support false, conclusion support false.
Right.
Okay.
No.
I think
conclusion because it's negated conclusion true.
Yes, but what I'm saying
this is counterintuitive in the wording, because
Well,
we want pro
It is,
when
that's
support
why
to be a
I'm not,
true and a yeah.
yeah. Should we change that?
Yeah, I have it differently as well in my actual code. I don't know what I call
What do you
the
call it?
variables. I have to check. I don't have it open.
Like in Gruff, I did just like is pro, right? Which refers to the purpose.
I like
of
pro
the-
premise, pro conclusion.
Yeah, that language isn't right either, although I like it better because it's pro premise. It's not negated premise. Not negated premise, true.
Premise
Original
true.
premise.
Premise true.
No. No.
I'm opening Visual Studio to double check.
It's cool.
It's because we don't have a language for the not negation. That's the problem. We don't have a word for the not.
In Aristotelian logic,
the originator. No, what we call what we call the originator claim, the originator, right? That's what we were calling it before. What do you call the first, the way the claim was written as opposed to its negation? We don't have a word for that, and that's why we can't name this variable.
Yeah, I call it, I think, a phrase, and then the other one is the inverse or the negation or something like that. I think that's what I do. I don't even disallow the original one being a negation, if you will. So you can say blah blah is false, and then the negation is not false.
Negation. What's the opposite of negation?
Affirmation. Affirmation. Oh yeah.
Affirmation.
Premise affirmed. Premise affirmed. Conclusion affirmed. How's that?
Okay. Or
let's try.
Affirmed.
What?
No, like let's try. I didn't know these words before, but if that's
I mean, it would be like affirmative. Premise affirmed, because the premise affirmed, it would be the negation affirmed, as opposed to you're not.
Well, if it's false, then the premise.
So you have the
denied.
affirmation and the negation, right? Those are the antonyms, right?
Yeah.
So it would be Boolean premise affirmation, conclusion affirmation.
Okay, I'm okay with affirmation.
Or affirmed premise. Maybe it's affirmed. Yeah. Okay.
I prefer affirm to affirmation, but I don't care hugely. Okay. But affirmed premise, I'm not as fun for whatever reason, because
whatever. Like we know what we're talking about.
Okay. Yeah, I feel a little better about this. We're getting closer.
And a side note, not that you have to pay attention to that, but I just, after a long loading session of Visual Studio, found it. I have an atomic statement, which is a claim here, which is simply as a title and an inverse title. And then my support is a relation statement, which has a root statement and a related statement. And I store the relation, which is either support or oppose, which is an enum. And then I say use inverse, which determines whether or not to use the inverse form of the related statement.
Which is the opposite of what we're wanting, because then you say true for when you're targeting the negation. Yeah. It's the opposite polarity that we want in this.
I think it works either way, but yeah, it's whatever.
No, it works either way, but already in our minds, we were setting the wrong values when we were giving examples.
So it didn't work.
So, yeah.
Fair.
Okay.
So this one or another one, affirmed premise, I'm happy.
I'm fine with this. Like,
I'm good.
It's the whole question is like if we get it right when talking about it.
Yeah. It's cool.
Okay, look at the.
Yeah.
So that this one is finished then, right? It's completed. Yes. Okay, next one is 19. Claim that is created in opposition to another claim can be identified as opposing the truth of that claim. So it's a support the negation of a claim. This is one. No, this isn't the one we just did. It's supporting the negation of a claim.
Yeah, it's support. Yes, exactly. So I think completed. It's fine.
Yeah. So in the top model, it would be premise true, conclusion false, and in the other one, it would be just the argument targeting the negation or as opposed to targeting
of the premise.
No,
yeah, an argument against the premise. It's the truth of the claim here.
Well, because now you're using the word premise, which is something we use to mean the one end of the argument, as opposed to.
No. That's exactly what it is. We have A supports B, and now we're saying, oh no, not A actually. So C attacks A. That's what this. That's how.
No, what we're saying is A. I mean, this is for A opposes B. That's what we're modeling.
No. I'm saying it's to another claim. I'm first looking at the other claim. I'm saying the original claim is A supports B. Okay, and now I want to oppose.
No, but the A supports B. No, A supports B is
the original
argument.
Is the origin? Yeah, the what pre-existed the opposition, right?
Right, but there's no in this case, it's the simplest of simplest things. It's just A opposes B. There's no pre-existing.
No, but we're not talking about the same A and B. That's what I keep saying. You're starting with the opposition. I'm starting with the other claim and other claim. So I'm starting with the other claim. I'm calling that A supports B.
But why are you complicating it? Why don't you just call the other claim B? The claim is B. The other claim is B. And now you're creating a claim to oppose B. So
okay,
that's what 19 is.
Yeah.
Okay, as opposed by.
It's that simple. Yeah.
Okay, yeah, you're right.
This is done.
You're right. Apologies.
Why is Jamie mentioning the truth in her examples?
She wanted, this is the previous exercises where we were trying to get use cases, and she wanted to squeeze into everything start of the discussion on truth versus relevance. She was trying to kind of find a way to get that into the model, and we've changed process, and so we're just kind of going over this and skipping over what her original intention was here.
Implicitly, it was already in there because we always assumed that A supporting B was about truth and not about relevance. We simply didn't have relevance yet before.
Yeah.
I mean, that's how I understood it, at least.
And now we have relevance in the structure, right?
That's why we
have something we call relevance.
We have something we call relevance, indeed.
Yeah. Yes.
I'm not happy with calling it relevance, but that's another story. But yes.
Yeah, but that'll come out if we have the right examples, right?
I agree.
I trust, at least. It's my faith. Okay, let's scroll down and see if there's other proposed stuff we want to do now, or if we want to do a round of proposing. Claim is denied. That's a user use case.
That's a process, yeah.
Process.
I would say it's scoring, but.
Yeah, I think we're putting a lot of scoring in process.
That's fine. I also fully agree that scoring comes after modeling. So.
Yeah, I think there are a lot of just argument structures. Right.
The process should probably be renamed as out of scope for now. I think it's gonna be less confusing.
Yeah, right. That makes sense.
I kind of don't agree with that because it's yes, fair enough.
It's not what I meant with process. Everything that's in there right now. That's my only pet.
Yeah, there are things that aren't processed, like user interface, for example, or whatever that isn't processed. It's just still out of scope.
Okay, well, we'll have to talk about what constitutes process. And okay, what would we call it?
Postponed.
Then? What?
Postponed. We'll pick it up later after we went through the original list, basically.
Okay.
Okay, support of claim A to claim B entails A supports all claims equivalent to B. So in this case, we're going to need to model equivalence classes, which means we would need to envision, if we're going to come up with an example, two statements that we've determined are equivalent as a starting point.
Oh, yeah, we need to add an example first, you mean?
Yeah.
Okay, yeah, fair enough. So outside of the example, I think we already discussed this and both models support it, but it's one of the reasons why I prefer mine, the top one, because it's less easy to abuse, the bottom one. But yeah, so let's go for an example.
My classic one is CO2 and carbon dioxide, just using synonyms, which is a bit cheating, but on the other hand, a perfectly valid example. CO2 supports.
I think we can do better.
Yes.
Let's take an
Sure.
actual equivalent claim that there's no discussion on for now.
I don't know if we can. It's really hard to come up with one. Like, I think it comes up in process because you have two people who simultaneously or created the same claim or didn't see the other claim, and that's why it happens. And maybe
then
you
Mark
use it.
Antoine's example perfectly fits.
Right, exactly.
We can look at the equivalent ones we listed way back on the glossary. I think something simple as a negation, like X is true, X is false is true. No, let me check.
Oh God, and how is that better than using synonyms?
Yeah, let's stick to synonyms for now. We just stating that they are claim instances as opposed to
CO2.
statements, multiple statements on a single claim.
Well,
right?
And by the way, I'm happy to enrich this with a different example if we have a non-synonym example, but I think the synonym example is valid.
Yeah.
It's good enough to talk about the concept.
Yes. I could even go into global warming, but climate change and global warming are not equivalent, but they might be intended as equivalent.
By the way, regarding equivalence, what just came to my mind, I don't know if we have it as a use case here yet, is that the support of something, like this support claim, can be equivalent to something that a user wrote. Like a user could have written out the whole argument, and this is equivalent to the claim that A supports B, for example.
Yeah, that's where incremental formalization comes in, basically.
Yeah, exactly. But still, like if we want to have incremental formalization, then this needs to be modeled.
Exactly. That's a good use case.
It's a good use case.
Add it, yeah, if you have the time, add it to the.
Yeah. So
Yeah,
what you're saying.
I'll do it.
Just
So we're saying,
but I think that, yeah, make it a different use case, not in this one. Yes, I think I agree.
right. So like here you would do like one, CO2 causes carbon change, and then say, and, okay. But you were using numbers just to.
Example.
No, that's a bad example, because I would say that CO2 does not cause climate change, is a negation of both of them. It's not in opposition.
Oh yeah.
Using circular logic, yeah.
Yeah. So it's a bad argument.
But this example isn't negation. This example is would both be opposed by.
Yeah.
It actually does happen. Argument mapping that you have people just saying it's true because it's not true because of negation. It does happen.
Yeah.
It will be
It's
opposed
circular
by,
reasoning, right?
Okay.
Well, fundamental disagreements, basically.
What are disagreement? What are typical counter CO2 causes climate change?
This is actually a supports in this example, so it can be a support of it. CO2 in the atmosphere increases.
Causes the greenhouse effect.
Yes.
There you go. Yeah. The green hose.
Greenhouse effect.
That sounds cool, not hot.
I agree.
All right. So this is. Yeah, this is something that is not explicit in the models. It's more the interpretation of the instances, right?
Yeah.
We do need an equivalence relationship, right?
And we have that.
And the bottom one has it.
The top one has it as well. They both have it.
They both have it.
Does the top one have it?
Yeah, the equivalence in the top model is modeled as simply the set of sentences that are equivalent.
Well, okay, this is a process question, but how are you getting them all in the same claim instance?
That's exactly a process question, but this is the model, so it doesn't matter.
But no. Okay, but no. It's not exactly a process question.
Okay.
Because, I mean, it is a use case question, but either you need to explain how your model prevents two separate instances having equivalent sentences, because you're magically merging the equivalent sentences into one thing. And there's no moment in your model.
You're deciding two
No,
sentences
no,
are
no.
equivalent, so this is how you represent it.
No,
The
no,
same
by,
way.
by the way, I
No,
didn't
but
say,
prior to deciding that, they are in separate places.
They don't even have to be. That wasn't listed in any of your use cases, right?
Okay, true. So what you're saying is that then what happens is anytime somebody creates an equivalent class or creates an equivalence relationship, there's an instantaneous merging of
No, you edit the original
claims
claim and you add an
negation.
additional sentence. It's a simple, it's a different.
no, Stephen,
No.
Stephen, it's entirely
No.
possible somebody created a new claim, not noticing the equivalence. And then after that, you
Yeah, but
notice.
then there are two separate claims with separate positive sentences. And then now we're talking about process of merging two claims.
Exactly.
I mean,
it's a valid use. It becomes a valid use case to say, oh, I didn't notice those were the same. Now I do, so I want to merge them.
Yeah. So in the top model, you would have two instances of a claim, and you would remove one and add the sentence of the other one to the former. That's the model manipulation you have to do. In the bottom one, you simply add a bidirectional edge between both of them.
And not only
and
that,
all the negations and all that stuff, by the way, as well, which is a problem with the bottom model.
And you also have to look at all premise and conclusion link and redirect them to one of them.
Exactly.
That's doable. I mean, it's expensive, but doable. I just have one thing I want to address, Tim. If I think it's entirely possible for the same sentence to be in two separate claims and the claims not being equivalent.
Sure.
I don't think that's relevant at this point, though. But yeah.
Right. It would be somebody decides that at some point somebody decides. Now, the model, Stephen's model, does not handle what is being considered is on the edge between process and not process, which is there's a debate over whether or not they're equivalent, right?
The bottom one doesn't support that either. Not
yet, but it's closer to.
Okay, but then following your process, you need to add that as a use case because.
No, I agree. It's not neither. Neither has that problem yet, right? For the case given, your answer is sufficient to say when two claims, pre-existing claims, are declared equivalent, they collapse into a single claim.
Yes,
right.
In the top model.
And the negations also collapse the negations aren't explicit.
Yeah, exactly. And likewise, I can make the same argument, except that it's much more complicated. In the bottom model, if that happens, then you need to draw like all the edges that are there. Which
you don't, because you can also do graph logic to find. You just need to draw it to one. And
no, we actually we added the anti-reflexive symmetric Yeah, did we decide in the past whether to materialize edges or not? I actually don't remember.
We kind of punted that.
We punted it. It's also one of those things that you just it's something you want to decide when you're starting to implement, right? Or when you're choosing between two models and you have to think of all the ramifications. But yeah, we can still punt on that, I think.
Well, when you said it has to be a use case, I thought this use case must exist, and yes, it does. A user asserts that two claims are not equivalent in meaning. The user disagrees with the assertion that two claims are equivalent, blah, 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 blah.
But the bidirectional edges will have to be there, otherwise how the hell are you going to implement it? Bidirectional equivalence edges are needed.
Yes.
And that's an implementation detail, because you can say you don't need to draw them in both, and if you look at the whole model, you can add them. But I mean, I'm guessing for similar reasons, the other edges will also be very useful to materialize all of them. Maybe, I'm not certain, but for the equivalence ones, it's obvious.
Yeah, I mean, you would want bidirectional for negation too.
Probably.
Because there's technically neither is the negation. They're negations of each other. So
yeah, I was wondering at some point, I don't know if it's a good idea at all, but would we want to have the notion that kind of this is the canonical language-wise negation. Like, for example, let's take my CO2 example. Like, CO2 causes climate change. Its negation is CO2 does not cause climate change. Carbon dioxide causes climate change. Its negation is carbon dioxide does not cause climate change. This is more canonical than the cross negation links, which are valid, but linguistically less obvious.
Right.
And do we want, so I've no opinion on this. Do we want to model that or not?
I don't think it comes into modeling. I think it's a different.
You could add it as a use case, I would say. It does seem like a relevant use case, but
right. But I don't see if it would come into the model unless
it would have to, right? Well, you could maybe automatically take the shortest one or something, but it does seem likely that you want to store the canonical one. But either way, we don't have to discuss it now because we're deviating.
Right.
I think both models support it right now, but yeah, it has a different impact on how to manipulate the model and that's normal because they're separate models.
Yes.
Right.
By the way, they exist as manipulation, but they cannot be reified yet. The assertion of equivalence cannot be reified yet.
No, but that's not the current use case.
Well, that was my intent when I declared.
Oh, okay. But then let's add an example.
Oh, actually, that I didn't declare this one, but so I can't speak about my intent.
But we were doing 29, right?
Right.
Yeah.
Oh, yeah. No, I agree.
Yeah,
we were doing 29. I was just pointing out that this other one may come at some point.
Yeah.
And I agree that there's two implication, one at the process level and one at the modeling level.
Agreed.
And we probably need to distinguish them. So,
okay.
But 29,
I guess,
I think we're fine with 29.
Mm-hmm.
Okay.
No objection? Hesitation?
Okay. No, but it's.
I have a hard stop in 5 minutes. Yeah.
Yeah. It's here where, like, where I mentioned before, for me, a good model is one that requires less operations to execute use cases like this. So that's, again, why I prefer the top one for this use case. But there might be likewise problems with the bottom model in case of other use cases we'll encounter later.
Yeah, each of the domains, like actually, when you start to implement, it depends on everything else, because essentially that argument is a bit of premature optimization. Maybe not. Once something is just too much mental overhead for us, it becomes clear that it's not premature. It's at a point where the model is too complex for us to envision how it's supposed to look. Yeah. That's a problem. So yeah, it can come up sooner.
But by the way, Stephen, I would even argue, though I prefer the first model, the top model, your model overall, I would even argue that what we said in this conversation outside of this use case was the claim merging operation is a non-trivial operation. So in terms of
right, that's one of those points about being premature is, like, I think in the future outside this scope, we're going to want to have those discussions of if something's equivalent and not, and blah blah blah. So we know at some point we're going to need those structures. But
I do still think the problem with the bottom model is combinatorial explosion. Like whenever we have we add entailment, an equivalence link, in theory we have to add all the other equivalence links.
No, we don't.
All the negation links.
Traverse. No, you can do a graph traversal. But again, that's totally inefficient, right?
Yes.
So all these, yeah. Right.
That's the explosion, I think he said. Yeah.
It's explosion in time or space.
Yeah. Okay. Yeah, I agree with that. And you know, every time I've implemented a system, I've done it with the top model.
Oh.
So
okay.
I've always started off. You know, my resistance to the top model is minimal. I just suddenly found the bottom model a little appealing in certain cases.
Yeah, and if we don't like the top one that we have to remove a claim, we can always make a group of sentences, a phrase, a new entity, right? And then you don't have to do that. You just update the phrase, which we also had at some point.
Well, we'll have to. look at
That's what we call the declarative sentence, I think, and then a claim. No, it doesn't matter. We can do it later if it comes up.
No, I think it just displaces the problem of merging on the phrase. I don't think anyway, we'll discuss it later. I agree.
Yeah.
The
All
supported
right, let's
claims,
squeeze in 30 in the last 2 minutes because it's
Yes.
identical almost to.
it's identical.
Yeah.
Do you really want
No, we don't
An
want
example?
Or copy paste it and just
Entails
add
all. The support of claim A to claim B entails all claims equivalent to A support B. Oh, okay. So it would be the opposite. I put the example.
yeah, it doesn't take time.
Yeah. So it would be so
With both
you could even-
support.
No. No, it's the other way. CO2 causes the greenhouse effect is equivalent to carbon dioxide causes the greenhouse effect, and both support CO2 causes climate change.
No, looks right.
Yeah, okay. Okay, that's right. Okay,
That's it.
perfect.
Great.
Okay,
Yeah. Then we're done for today.
we are.
Yep. All right,
See you
cool.
Friday.
Again, see you on Friday.
See you on Friday.
Bye.
Happy St. Patrick's Day.
Yes.
Happy St. Patrick's Day.
The only American here.